Digital transformation is playing an increasingly important role in the mining industry. Digital technologies such as artificial intelligence, machine learning, robotics, and automation are being used to increase efficiency and reduce costs. The use of data-driven decision-making, geospatial technologies, and 3D modeling is also helping to improve mineral exploration and resource management. Additionally, advancements in the Internet of Things, blockchain technology, and virtual and augmented reality are helping to improve supply chain traceability, mineral rights management, and mining operations. The use of AI-enhanced technologies can also help to mitigate the environmental and social impacts of mining operations and promote sustainability and transparency in the mining sector. To fully leverage the potential of these technologies, companies are investing in digital infrastructure and training workers in digital skills. Please welcome speakers of the last session of the forum, who will present cases of the implementation of digital and automation technologies to make mining in Europe smarter and more efficient. Stay with us to explore how technologies are not only driving innovation, but also promoting sustainability and transparency in the mining sector.
Okay, I think we've got a green light here. Welcome to everybody this afternoon for the last session on automation and digital transformation. I can honestly say, after many years working with Arthur and the MINEX team, that he always leaves the best presentation sessions till last, usually to keep people hanging in until the last. And so we've got a really interesting set of presentations today. It's been great to meet the presenters. Now, on those themes, I know a little bit professionally about each of the topics, but as they say, a little bit of information can be dangerous, so quite looking forward to hearing the individual specialists present. One thing that I do see looking through all the topics to be presented is that they have very positive common themes for the mining industry. With overlaps, they're positive in improving safety, reducing impact on the environment, improving efficiency, whether that's through time or cost, increasing productivity, and improving accuracy. So I'll hand it over to the first presenter there, which is Jacek Kolas, and he will be giving a presentation on pre-concentration through sorting technologies. So thank you very much.
Thank you, Mr. Chairman. Thank you, ladies and gentlemen. I have a pleasure to present something which is related to the, in our opinion, interesting method of processing of minerals today. My presentation will be about metal pre-concentration based on the pre-con project, but generally I would like to say mainly about sorting. Just a quick introduction of our company. Our company was founded in 2003 as a startup from a university in Trondheim in Norway, and in 2007 we had a division in Poland, in the southern part of Poland, and I'm myself the founder and the president of the COMEX group. We work with different technologies. We have particle technology, which was the beginning of the company activity, and sorting of minerals was actually started later in 2007, 2008. We basically deliver to different mineral industries, chemical industries, electronic, recycling. It's where the sorting is necessary. Our customers are basically in all continents except Antarctic, but you never know who can start activity there as well. Basically, I would like to say about production of and pre-concentration of minerals, because basically we have a critical minerals issue today, and this creates a problem for many mining operations. We are actually, we face a very low concentration of minerals we are interested in. It's just in ppm level. If we have few percentages, we say it's a very rich ore, and we generate a lot of waste. So basically we are like on this slide, we see the This is the image from the gold mine, where we see just the veins of the minerals which are interesting for us, but we have to unfortunately mine the whole face with a lot of waste included. So as a consequence, we generate a lot of tailings, which is a growing problem. So where we can use the pre-concentration? Basically, normally we have the operation like this. We have a run-of-mine material processing, we generate waste and product. In case of pre-concentration, we place the sorting unit or sorting device as close as possible to the mine, to the mine face. What we do is we create the waste fraction in the very early stage in the form of the very big pieces, so we can actually reuse them. We can sell them as a secondary product. So basically, it's possible to use them for constructions, for example. We, of course, reduce the transportation cost to the mine, to the processing plant. We reduce the cost of processing, obviously. It's a lot of complicated stages like crushing, milling, flotation, drying, and so on. And of course, we reduce the waste amount, which is very important, and sometimes increasing the quality of the final product, very often actually. And surprisingly, all these advantages can even take place simultaneously. So there's a huge possibility for reducing the energy consumption, reducing the carbon footprint, obviously, and lower cost, reducing the cost of operation, overall cost. And very important issue is that water consumption is reduced in many cases because it's a dry technology. So in very cold or very hot climates, it's sometimes critical. How do we do it? It's we call intelligent sorting. We know optical sorting from before. It's just a very narrow area of the electromagnetic spectrum where we see the colors. And this was used for many years in the past, how to separate minerals from each other. But we try to apply different other technologies, like near-infrared, which is just below the visibility level. We use the short-wave infrared, which is a little bit far from this limit. We use the ultraviolet from the other side. And the most important and most interesting is the application of X-ray, which can go through the material and we can see the inside of the material. So here is the movie showing how the machine works. It's basically, yeah, I think we need a little kick there. Yeah, fine. Its operating principle is it consists of the vibrating feeder, which is distributing the material in the monolayer, because we need to see the particles from the top. We have the X-ray gate, which is just similar like we have at the airport. There is a set of different other sensors, like cameras, which send a signal to the computing unit. And then we control the nozzles, air nozzles, which are just rejecting the material we don't want. So the material is analyzed it's going through the sensors, it's analyzed, decision is made within couple of milliseconds, and then we control the nozzles to remove the material. This is the real application. It's the first, actually, by the way, it's the first application of coal sorting in China, sensor-based sorting. So the material is coming in the vibrating feeder here. It's quite a good capacity, 70, 80 tons an hour by 1 meter unit. It's one of the smallest units we have. The material is accelerating on the sliding plate, reaches the speed of the belt, with 3 meters per second, goes through the X-ray unit. And here we see the nozzle operation, where the material is separated from the bad particles. I mean, the rocks are separated. The slow motion, you see it much better than. It's a very short time for rejecting the particles we don't want. So basically, it's basically 1 millisecond accuracy. Actually, it's a 500 microseconds accuracy in the equipment. So that's a very high precision unit. What can we see by X-ray? We see the iron ore, basically don't see anything. If we use the X-ray, we can identify for example, the yellow areas which are very, very rich in iron, and the blue areas which are completely empty it's just a rock, just a regular rock with a density of 2.5, like calcium carbonate or sandstone. So the machine is actually describing every particle separately, like on this image. The yellow parts are the interesting part. The blue part is the waste rock. So by each particle is described by different parameters, and so every couple of milliseconds we have a decision if we should remove it or not. What we do in addition to the visible light and X-ray, we combine the infrared images. And hyperspectral imaging is one of the key issues here. What is the hyperspectral imaging? Normally we are using the RGB, the visible light range, which is 400 to 700 nanometers. This is the light we normally know every day. But hyperspectral imaging is the spectrum from 900 to 2400 nanometers, which is far from the visible range, and we have up to 256 channels. In practice, it's a very easy example from our life. We have a hand. One of the fingers is not receiving enough blood, so the oxygenation level can be described by this hyperspectral imaging. It's not visible by regular looking at the hand, but it's visible by the hyperspectral imaging. So, of course, in minerals, we see a lot more than by visual check. Like on this image, we can identify different parts of minerals. We can see the groups of minerals or different rocks. So what we do is we combine these signals. So this is the X-ray image. It's a sensor under the belt, as I mentioned, as I showed you on this movie. This signal is sent to the farm of GPU-based computers with a teraflop capacity. And in addition, we are receiving the signal from the hyperspectral imaging. And these signals are fused together in one machine. So this data fusion gives us a description of much more than we can describe by any of these sensors separately. So it's a beauty of combining two sensors by not changing the position of the particles. So that's very important. So it's much more flexible for identifying the particles and its composition. So as a result, by applying these sensor signals and some AI models, we can build the image of the rock, like on this example with the drill core, where we can see the mineralization, and we can identify the waste rocks. Of course, during sorting with this high-speed identification, we don't have such beautiful pictures, but it's enough that we have the signals that this is a bad rock or this is a good one. So it's enough for separation. All this was done by, thanks to a lot of development and research work, which was financed quite a lot by EU funds. This is the example of the project which is running right now together with the Łukasiewicz Non-Ferrometals Institute and KAGM Cuprum, and this is for the aim is pre-concentration of zinc and copper ore. But in the last 10 years, we have used over 10 million euros actually for research work. So in this program, so we invested quite a lot in the research and development to achieve good results. Because the most important thing is that you have to, when you do sorting, any sorting, you have to produce the waste fraction which doesn't contain interesting minerals. Because if you are starting to lose the minerals there, then this process is not interesting for anyone. So it's very important limit. How we do it? This is our test center, which we have in the southern part of Poland, where we have machines operating in industrial scale. This is the example of the sorting machine, which is sorting and mixing the stream together. So its material is circulating in the system. So we are simulating the high capacity operation and sorting capacity, where we are happy with the result. Then we can reverse these belts, which you see on the bottom of this picture, and then we have the separation test done. So we can produce samples, real samples in a good scale. So we adjust the parameters during the process, and then we have the final result. This is absolutely necessary for the final customer. After that, we apply the big industrial scale. It can be in the tent or it can be in the industrial building. Here is the example of one of the ores which we applied for, where we applied our sorting machine. It's a zinc and lead ore, starting with a feed of 1.1 lead and 8% zinc, quite rich ore. But unfortunately, this ore was not really not all particles were the ore. It was a lot of waste in it. So we enriched it to 80% of the stream, which contained 1.3 over 1.3 of lead and 10% of zinc, with quite good recovery of 95 to 99%. And the waste stream was containing the amounts which are completely below the cutoff grade. So 20%, as you can see, of the material was completely unnecessarily processed before. And this mine is 10,000 kilometers from the processing plant. So there was a huge saving on the transportation cost. Another example is the copper ore, 1.4 copper, quite disseminated ore. And this was enriched to 1.66 with a recovery of 97.5. The most important is the recovery, basically. So we are losing only very little in the waste, but it's about 15% of the total stream. And this is also below the cutoff level, which is 0.2 copper in this case. And our most spectacular example is the gold and copper ore project in Brazil, in the middle of nowhere, in the middle of Amazonas. This is the equipment we installed with the screening and preparation and transportation devices. And here is the result. On top, we can see the input ore, 1.2 grams per ton of gold. And on the left side, we see the waste stream, the product stream, which was 5 to 6 grams per ton upgraded. And you see the 15% very small amount of product containing gold. On the right side, we see the waste stream below 0.5 grams per ton, which could be still reduced, but this was for this customer, it was a limit, economical level for further processing, and this was 85% of the stream. So basically, this company produced the same amount of metal because they have smelters as well. The same amount of metal, but processing only 15% of the initial stream. So you can imagine the savings and the reduction of tailings and so on. So conclusions, we have the situation where the new pre-concentration technologies, they represent really the huge progress in this field and in mineral and mining industry. We can change the negative image of mining, which we discussed a lot today and yesterday. The new technologies can improve the economic and technical conditions in current processing plants, but they can also create new possibilities for mining installations which were not feasible or treated as not feasible in the past because of these contamination or environmental issues. And finally, we see the possibilities to produce efficiently many critical minerals like copper, rare earths, lithium. We have a possibility for reducing water consumption, drastic reduction of processing waste from at least 15 to 20% and even up to 80-85, like I showed you with this case of the Brazilian plant. And of course, we have a corresponding energy reduction, carbon footprint reduction, obviously, as a consequence of all these advantages together. So without any doubt, sensor-based sorting is the future. Thank you very much for your attention.
Thank you very much, Jacek. It's a great topic, really interesting for me. But before I ask a question, are there any from the audience? No? Oh, sorry.
Right.
Please go ahead.
I'm Mark Tang from SRK. Quick question in terms of calibration period. How long does it take for it to be calibrated for an operation? And would you recommend it for a shorter life of mine kind of operation?
Well, calibration is obviously a very important topic. We have, I showed you only the industrial units. We have test units as well, small scanners, what we call, which are compatible with our industrial scale equipment. So these scanners are used in a laboratory for calibrating the parameters because it's a very complex problem. Especially X-ray analysis is very complicated. So we need a lot of models, we need a lot of approaches, a lot of tests. So these scanners are allowing us to test the parameters in a very small scale with a small limited amount of material and under very controlled conditions. And after we are ready with these calibration curves or calibration parameters, you can just transfer this, what we call sorting file, directly to the machine operating even online. You just need to switch off only the machine and load the program and turn on again. So that's basically the necessary procedure. But of course, for the new customers, we are doing this step by step. We do the first scanning, then we do this pilot plant like I showed you, with a more high capacity operation, a couple of tons of the sample, and then we apply the real industrial scale machine, which could be also in the container. It could be also a mobile container. In case the company is still uncertain about the operations, we can sell or we can rent the container-based machine for 1 year or half a year, and then convince the customer, this is obviously, mining is not an easy area to work with, especially with the new technologies, so it's a necessary procedure.
Any additional questions there from the audience? So big question for me is for a lot of our clients, you know, sorting is a huge opportunity, and clients don't start taking action on sorting until, you know, it's too late to sort of include it within studies for financing and so on. How busy, I mean, you know, laboratory capacity, you know, how much are your labs booked up for 6 months, and or is there availability, and you know, how long does it take typically to run a batch of processing to deliver the answers that are required?
Yeah, it's first of all, as I mentioned, the first approach is that small sample. So we just get an answer: is it sortable or not? Because obviously not every material can be sorted, because if it's very disseminated material and very disseminated mineral, then it's very difficult. So the first approach is just to check the sortability. Then we do the bulk testing, what we call that. That means we operate with a couple of tons, and that takes time. So basically, it's 1 week. Operation to provide the real answer for the customer before the decision can be done. So we are basically doing it almost every day. So it's our lab is maybe not booked for half a year, but let's say for 1 month at least ahead. It's a queue of minerals waiting for, or materials waiting for the test. Not all of them are successful, but at least 80%, 70% are with at least positive plans for the future. That's very, very important. It's not maybe necessary that they are applying it a month later, but if they only consider it as they plan it in their strategy plan, then it's very important.
Okay, thank you very much. That's much appreciated.
Thank you.
So moving on to our second presentation, we have Faviva Rafii from the Weir Motion Metrics Group. So leave it to you, mate.
Hello, everybody. Thank you so much. I know it's the evening and everybody's tired, want to go home, so I'm going to try to be quick. So what I'm going to talk about is about what we do as a technology company dedicated for mining and basically queries. Motion Metrics was founded in 1999, started as a startup from University of British Columbia, and then slowly grew up to where we are today. In 2021, Weir Group, Weir ESCO Minerals, they acquired the company, so currently we have a lot more reach with the help of ESCO and Minerals. This is our team since last year at our AGM. We are very international. Our products in a lot of mines. We are located in we have products in more than 80 mines, in quarries, portable devices that I'm going to talk about them. We have offices, again, around the world in major hubs for the mining. We have a line of products, we call it ecosystem or mine-to-mill optimization. So we have a line of products from digging for equipment like shovels, loaders, a handheld device for fragmentation background, scanning the trucks, and on the belt. So basically, like, you know, if a mine be interested, we can provide the line of products from digging all the way to the processing unit. So the challenges in queries or mine, like especially in queries, is blast analysis, inconsistent material size, which can cause a lot of waste for the queries, wear and tear on equipment, energy consumption, and safety. So we can provide basically our solution, which we call it belt metrics, which is a 3D camera. And by doing image processing, we can provide basically particle size analysis, fragmentation with accuracy of within like 3% at PAD, that like, with the sieve analysis error. Empty belt detection, you don't want your belt to run empty. We send like a live warning when the belt is empty, or like, your PAD changes, you can get a warning within a few minutes. Volume monitoring and load profiling to prevent damages and wear and tear of the belt. We started to do 3D solutions with a unit that we call it the Portametrics. It's a 3D tablet that a lot of blast companies and mine are using it. And it's a very simple point and shoot device. You just point to the face or stockpile and take a picture, and you'll get the segmentation result right away. The same thing goes on the belt metrics, but a different camera that works with the movement of the belt. We can work up to belts with the 8 meters per second. It's just a 3D camera, lens cleaning, and lights. Very simple. You install it, you forget about it. Just get the data online, or basically like through our platform, or directly pull from the database. One of our main strengths is machine learning and AI, which we started about 9 years ago by hiring basically some very bright PhD students on that line. And one of our major breakthrough was providing very exact segmentation of the material on the belt, on the trucks, on the bucket of the shovel, or the handheld portametric device. So we don't make mistakes on segmentation. Like, even if somebody sits and tries to do this with hand, they cannot reach the perfection that we do with the AI. And within a few seconds, we can provide all the P numbers for you, all the baskets that you need for basically doing a better analysis of the material for your next blast, or the material that goes to the crusher, or on the processing. We provide this with the same system volume monitoring, and basically you can see that the 3D imaging and 3D map that every image provides for us. And with that, we can provide profile, volume, speed, all those, speed of the belt, all those can provide it with one system. This is one sample of the system installed in a query. They want to see the product that they have has a unified size that fits their purpose, and we can provide it for that. As soon as the size changes, we can send a warning for them, either SMS or email. And we can provide different KPIs with the cloud-based reporting. So you can just, in the office, see it and basically log in and generate the reports that you need. And these are some samples of installation, different line of the mines. You can see that the installation easy. You just need control lighting for making a unified results for that. And basically, we try to answer the challenges of the mining and queries with our solutions. So those are some of the challenges that you can see in everyday working: the PSD consistency, screen breakage that can cause oversized material going to the belt, damage the belt, or they down the road in the processing, screen blockages, crusher gap changes, belt speed regulation, belt wear and tear, and doesn't matter if it's dusty, dark, we provide lens cleaning system for that, and estimate weight, access to data for decision makers, and belts basically doesn't matter if it's in a remote location. We can provide the alerts via SMS, even if there is nobody available to monitor it. This is one of the samples that happened in a mine in Australia. So one of their screens broke, and oversized material started hitting the belt. We notified the mine within like a few minutes. They stopped the production, fixed the screen, and back to normal operation. So that I heard from a mine that something similar caused 25 kilometers of belt damage in one mine. I won't say where, but that's the big issue. And all of the information, as I mentioned, doesn't matter if it's a shovel, a loader, handheld device, belt, or truck, we provide it online. So you can basically see the results online. And these are like the dashboard that we have. So you can have different belts and you can see all the results like within one screen, all the KPIs that you need. And generate different kind of reports. Very simple. And that's it. Thank you so much.
Thank you, Fariva. Any questions from the audience? I had half of my question answered from the presentation, but I was just curious. So you have your own interface for the data reporting, you know, whoever has access. But is it typical to integrate that into another system on site? So
yeah, very easily we can provide API, and the data can be integrated to the mine software that the mines use or queries use. So they can either use it through our platform, or you can just like pull the data directly.
Brilliant. It's good to understand that, how compatible it is.
Yeah, it is. Yeah, no problem.
Okay.
Thank you so much.
Thank you very much. Okay, so now our next presenter is on the geophysics side, Tim Archer, Managing Director for Reed Geophysics, and looking forward to learning about machine learning with the geophysics topic. Thanks, Tim.
Thanks very much, Chris, and good afternoon, ladies and gentlemen. It's great to be speaking again at MINEX. Thanks again to the team, to Arthur and his colleagues for putting what I always find is a thought-provoking and very efficient way of sharing information. And from our tiny corner of the universe, I'm going to share something we're quite excited about and hopefully should cheer up some of the geologists in the room. So finding mineral deposits, I'm taking you away from ore sorting and the clever things we've seen in the last couple of presentations, finding the feedstock in the first place. And I think we can all agree it's difficult. We've got the whole of Europe, we've got the whole of the world, everybody needs it, but where do we find it? And so, of course, geophysics comes in, and I would say this because I'm a geophysicist, but it happens to be true, that you can cover an awful lot of ground non-intrusively using geophysical techniques for the cost of a single, that's a 200-meter sort of standard cost profiled borehole, too small to show to scale on this image, but with something like aeromag radiometrics, we can get up to almost 200 square kilometers. Some of the ground-based techniques there in red on the left, obviously a smaller footprint, but more detail. So we're just part of the chain. We're part of the risk reduction in bringing people to putting the hole in the ground in the right place. And there's ways to do that efficiently. What do we do? We're a small consultancy based in the UK, but assisting clients worldwide. And we do pretty much everything that you'd need us to. We're kind of thinking about geophysics. Is it a good idea or a bad idea? Sometimes it's a bad idea. If you don't have a physical contrast, you're not going to see it. Survey design, we've got a network of contractors that we're at arm's length with, but we can recommend for particular projects. So we'll review their bids and keep you guys safe through the contracting process. Quality control, the data comes in. Does it look like what it should look like? Processing and interpretation, we then enrich those data to turn it into something that's meaningful for our geological clients and downstream clients, and that's really what I'm talking about today. And then training. What we do is kind of weird, so we're very aware of that, and what we try to do is explain to people that hopefully it's not quite as weird as you might think, and that we can transfer some of that knowledge. We particularly find this is useful for government clients, so they really want to upskill their workforce, the effectiveness of that is a separate conversation, but the intent is good. So always happy to talk about what we're doing. This is just an important point. We don't acquire data as a company, so we are independent. And what that means is we can give you impartial advice about the best techniques, the best contractors, and what have you to use based on our experience. So we see that as a particular benefit to you as clients. So we're going to talk about machine learning. Hey, everybody's talking about machine learning. You've probably seen machine learning done badly, just as often as I've seen machine learning done badly. It's not a silver bullet, it's not as easy as you think, and there's 100 good ways to get it wrong. So we need to be careful. We're going to talk about the area of interest and some ever so basic version of a couple of the techniques we've applied. Just a shout out to my co-author, Artem Gubanov. He's a young, smart geoscientist, been with us a couple of years. Most of what I'm presenting today is his work. I'm very happy to acknowledge it as such, in part because he does scary things that I don't even know about. So hard questions go to Artem, easy questions and work opportunities come to me. Thank you. Modeling results, work in progress. We're pushing the envelope here and just wrapping up with a couple of conclusions. Why bother with machine learning? We've done it the old style way for 100 years. What's bad about that? Well, the answer is not always an awful lot. But machine learning, as data volumes increase, it's extremely fast. It is objective in as much as I'm old enough to have confirmation bias and crusty geophysical ideas that may or may not be appropriate to a particular deposit. So the machine can challenge my preconceptions, or any of our preconceptions. It's scalable. What do I mean? You can start with a patch of ground in wherever it is, South Poland, or you can run an analysis countrywide or even regional, larger than that scale. You just need a faster computer, or more accurately, you need a bigger piece of the cloud. Put it all up in the cloud. The cloud sorts it, and you make sure to analyze the results carefully. There's a limited requirement for a priori information, and that helps with the objective, reduces confirmation bias. Some of the algorithms we employ, here's a bunch of data, tell us what's in it. And of course that'll pick your noise, and of course it'll pick the bad sample up in the top right corner, but it'll also give you an objective assessment of what you've actually got in your data. We're not off the hook. We can't go and drink coffee. We've still got to kind of do our intelligent value add work, but the machine does, a bit like we were seeing with the sortering on the belt earlier. The machine gets rid of the gubbins, and we can keep the stuff that is important. And it's data set agnostic. What I mean by that is we can develop algorithms now that will handle grav data, mag data, structural observations, a whole bunch of different feedstock to continue the image coming into the top end, and we can still make sense spatially of the results. So I'm taking you to Sierra Leone today. This was a lovely project that we were privileged to be the quality controller on, World Bank funded. They flew the whole jolly country at 150-meter line spacing. So prospect scale resolution for a national data set. And it was great fun. 560,000 line kilometers of data. So a fair bit of going on. Magnetics and radiometrics, I'm not going to go into the details of those. I'm sure many of you are familiar with those. As a baseline, you're scanning a large area, run your mag and radiometrics, you'll get it for $15 a line kilometer. Then you can send in the more heavyweight geophysics and the intrusive tools later on. So some lovely imaging, I'm not going to dwell on that, but we took a small pocket of it, and this is Loco Hills, top left, as you can see from the center tiny image, perspective for gold. There's Archean greenstone belt running down the middle of that patch. And this is the scary slide. So Artem has looked at convolutional neural networks and self-organizing maps. At a headline level, convolution neural network, CNN, possibly an unfortunate acronym, is supervised. It needs training data. So we say, this is what something or other would look like in the data. Now go and find things that look like that. Self-organizing maps is different. You dump the data in the top. There's a bit of preconditioning, but not a lot that needs to go on. And it self-explores the patterns in the data. So there's two ways of running machine learning. CNN and self-organizing maps. And the papers are here in a tech ref at the end if you need that. So this is a busy slide, but it tells us, hopefully, that we thought about what we were doing. We injected various combinations of the geophysical data and the terrain into both these algorithms. Just headlines again. So self-organizing maps goes in and explores for data similarity in N space. And we developed 13 clusters. There's ways you can get more clusters, less clusters. There's a whole conversation around that. The convolution neural network, Artem ran 1.7 million models. Again, it sat in the cloud, so we kind of didn't care. But that's the volume of interrogation we're talking here. And we developed that from that a training set. And when we ran it, we got 92% modeling accuracy on the training and 91.5% on the test set. That's a pretty good result. Pretty pictures, enough of words. On the left is the initial result of our SOM clustering. So this takes the data sets and just says, what are the patterns in the data? That took about 20 minutes to run. On the right is the high quality manual interpretation delivered by the contractor for this project. That's, hey, 3 days if you're up and running. So 20 minutes on the left, 3 days on the right, and arguably there's more information in the image on the left. Now, I want to be clear, and this is a health warning, what we're seeing on the left is not a geology plan. It is a spatial representation of the self-similarity of the input data. And that's a long set of words, apologies to the translators. It's an important distinction. Too many people I've seen have run off and said, oh, great, we got a geology map, let's go drill it. No, 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 no. What happens next, please, is go in and do your site work, your field mapping. I'm geology undergrad. Ultimately, you've got to bang on some rocks. But what this does is it vectors you straight in on either a regional data set or a national data set or whatever to the bits where you need to put boots on the ground and the bits you can safely leave alone. Yeah? So it's a link in a chain. It's not a magic answer to all of our problems. But we hope that it gets rid of the subjectivity of the interpreter. It gets rid of the need for extensive, we've all drawn lines on a map. Yeah, it's not as much fun as it sounds. So let's get the machine to do the bit that's boring, then we go and find the ore deposits that are interesting. CNN again, so our results on the left. Now Euler deconvolution, for those of you who know much about GravMag, has been around for 40 years. And it works okay. But Euler deconvolution gives you depth to magnetic sources. So and the magnetic sources are proxy for the geology sources, so you're mapping up throws and down throws and structural discontinuities and what have you. On the right-hand side is some good work. This is commercial stuff, lineaments. So you're looking at your magnetic data set and seeing where are the lineaments. So the old school is Euler deconvolution and CET lineaments. What we're offering is the image on the left. And frankly, on this bit of the block, Euler decon's not doing a great job. You can't really see structural trends. You can't see uplifts and downlifts. And the lineaments is just really, there's almost too much going on, isn't there? So we feel that our result on the left, again, this is that the training takes time up in the cloud, but applying it to a data set is minutes of work. Gives a better job both of, you can see the spatial continuity. If I go to the next image, which is kind of a zoom in, that middle bit there is showing good spatial continuity of these magnetic lineaments. We can start to turn it into, the whole mantra of this presentation is turning the geophysics into the geology, okay? We're not there, and that's complex, and we may never completely get there, but how many geologists have we got in the room? Any geologists? Right, so we've got a few. You guys are sick and tired of looking at rainbow-colored geophysical images. You just want to know where to drill, yeah? And we get that. So what we're trying to do is interpret, in the general sense, the geology, the geophysics, and move it closer to the geology. So both SOM on the left, CNN in the middle, we think are helping with that. And again, just the geology map on the right, or the pseudo-geology, because that was, again, a geophysical, a manual interpretation delivered by the contractor on the right-hand side. This is, again, a busy slide, but it's important because it's part of the whole message of turning the geophysics into geology. What we've got here, I'm not going to dive in on the detail, but the channels there lit up in red and green are the input layers to the SOM classification, the clustering. And if you can see in tiny writing in the middle of the slide, we're then making inferences of what kind of geology would have high radiometric ratios or strong magnetic content or whatever. So we're then able to cluster the SOM output and turn it into pseudo-geology, which hopefully hopes you guys out on site making sense of all of this. Just a little bit of a look over the medium horizon. The work I've shown you today has been published in one of the leading journals, and you can go and read that or just talk to me or Artem. What we want to do next is get to what are genuine structural discontinuities, not just jinks in the magnetics or things that a geophysicist dreamt up after hours. What is actually going on here geologically? And that, you'll find out, is more complicated than you think. As humans, we look at the three images bottom left, and we can immediately see, oh, there's a discontinuity there. Getting a computer to do that, particularly when you put in a bit of noise, is quite a difficult task. So these are very much preliminary results. We've got a magnetic image on the right there and some unit outputs in the middle. We're on the case. What we want to do, again, is to make your lives easier, but not easier by cutting corners, easier by thinking hard about how we can push the geophysics a bit harder. Okay, and that's what we're going to do next, hoping to publish on that early in 2024. So ML, carefully constructed, can enable fast objective data analysis, scalable, limited supervision a priori information, and can be designed to handle different data streams with almost equal efficiency. We've demonstrated this using an example from lovely data in Sierra Leone. It can be used on ground data as well. Normally ground data are over smaller areas, and you know, there's challenges around that, but it can absolutely be used for ground data or indeed offshore. Structural discontinuities, watch this space. And although these tools are really powerful, they still need to be wielded by competent geoscientists. The machines are not going to take our jobs, but hopefully they will make our jobs easier, more efficient, and in a world that's desperately hungry for the resources that we're all finding, that matters. Just want to acknowledge the government of Sierra Leone who gave us permission to present. A bunch of technical references, and Artem's smiling face on the left, and you got the ugly guy today, so that's me on the right. Thank you very much.
Thank you, Tim. Any questions from the audience on this topic? Okay, I had a couple, and diverting away from the plan questions. How do you handle, I mean, the amount of data must be insane that you're dealing with there, and, or am I wrong in thinking that? And, you know, where do you get the capacity for that? Do you have that internally, or are you using sort of cloud servers for processing?
I'll come back. It really is cloud-based, and this has been a step change for so many of us. I'm sure for you guys with your ML algorithms and so on, it's not workable. There were a couple of valiant efforts about 5 years ago to run it on a PC, and it's just not a good choice. So much of what we do now, we do the preparation stage, then we upload the data volume, and there is a conversation there about how do you minimize the data volume so that even on the cloud, you know, you're paying by the hour or whatever, you want that to be reasonably efficient. So there are decimations that we run, and those need to be intelligently applied, otherwise you end up losing, you know, the information that matters, the detail that matters. Yeah, cloud-based for sure, and then we push it up in the cloud. It sends the results down. And then the important part, and I've labored this point, but I'll do it again, is don't just assume it's the right answer. It's just an answer. You still need the brains to interpret and say, is this sensible? If your input data is bad, your output data necessarily are going to be bad. So you know, that's an easy one, but there are subtleties as well. So it's worth knowing what you're doing. And you know, we're excited, but it is just a tool. Yeah?
And second question, you know, I can see, you know, the amount of data and the way that you pick up the data is, you know, seems to be a very good opportunity to piggyback off and collect data for other purposes. For, you know, is there other data that's collected in addition to geophysical data when you're running these type of surveys, something related to the environment, or water, surface water, or is it just purely focused on geophysics when you run these surveys?
Yeah, thanks. So I say to people, and I've said to a couple of people at this conference, geophysics doesn't find ore deposits. And they're like, oh, what, shock, why are we using it? What it does is map variations in physical properties. So you've got to think quite hard about what you're trying to get out of the survey. And a lot of our work actually gets done long before the glamorous part. You may have seen the flying donut over Cornwall in the UK, and it's a weird-looking piece of kit. It puts an electrical field into the ground, but we actually did the survey design on that. And you've got to think, what are you trying to find, and therefore can it be found geophysically? So if that's groundwater, you need to design a system that's probably going to be focused on the shallow subsurface. If that's something like deep-seated deposits, we all know ore deposits are getting more difficult to find. They're getting deeper, they're getting smaller. So what we're seeing now is a lot of development in the geophysics space of deeper-looking tools, and that brings challenge, because in general, the further away you are from the source, the poorer the resolution. So, you know, how do we fix that? So in general answer to your question, we can find different things, have different applications using similar tools, but you just got to think about it carefully before you, please don't go and just start collecting geophysical data. It will burn you. And I've had too many people who've just gone and, oh, we need a geophysics survey. And I'll say to them, well, why do you need a geophysics survey? It's a really important question to have fairly clear answers to in your own head. Don't just commission geophysics for the sake of it, please.
Thank you very much, Tim.
Thank you.
And thanks for the efforts of the presenters for keeping on time. You're doing very well. So the next presentation is Stefan Ebran, who is with the Aramine Mining Equipment Group, and look forward to hearing on latest technologies with this equipment.
Good afternoon, everyone. I'm Stefan Ebran from Aramine, Sales Area Manager, and I'm delighted to tell you today more about designing the future of mining. Who are we? Aramine. We are a French-based company active on the equipment and spare parts market for 50 years already. We are headquartered in southern France, in Aix-en-Provence, and we are present internationally through our subsidiaries in Mexico, in Africa, in Poland also. We are internationally French. We have more than 20 nationalities in our teams, multicultural, multilingual, and we sell equipment and spare parts all over the world. Let's have a glance at some historical key points. We started by doing standard exchange of components for our customers. We took their used components and provided them with new ones. Then we started remanufacturing components as well as whole equipment for our customers, and then we started selling spare parts. In the years 2000, we started our own range of equipment. As you can see, we started with loaders in the 2000 years. We started first with diesel-powered equipment. Then we electrified our equipment range, and today we produce battery-powered equipment. Before that, we made dealership partnerships with a major equipment manufacturer like Epiroc and Normet. You know. Why did we open our subsidiary in Poland almost 2 years ago? We wanted to develop our presence in Poland, but also throughout the region, in all the Central and Eastern European region, and to bring KGHM the highest standard of service and support for their equipment and supply them with spare parts. How did we do that? We joined our force with our local partners who had better knowledge of the local market. We invested a lot in tools, in equipment, in local stocks. Some figures about Aramine Poland. We have here a big subsidiary, office, workshop to provide spare parts to our local customers, and also workshop to remanufacture equipment and components. We have invested more than €1 million last year when opening our subsidiary, and we have 20 qualified people in our staff here in Przemków, north of Wrocław, where we are. Now let's have a glance at our CSR vision. As you might know, we are a pioneer in sustainability in the mining field. We started with standard exchange to remanufacture components rather than getting them to the waste. Then we started remanufacture of full equipment in the 90s. And we started to design more sustainable equipment, first with who were first electric powered, and then today we sell battery powered equipment. We have launched our first battery powered loader in 2018, and next year hopefully we will launch our second one. what is our ambition? What's our commitment toward a more sustainable future for mining industry? A more sustainable, a more efficient, and a more humane mining industry. That is our ambition for the future. Now let's have a glance at our battery-powered sustainable range. This is our last loader, which will be hopefully commercialized next year. Here you can have a comparison between our first battery power loader, which was launched 5 years ago, and our new one, which will be launched next year. As you may notice, it is much more powerful and much more efficient than the previous one, especially for the payload. What are the advantages of a battery-powered equipment? With a battery-powered equipment underground, you have no CO2 and no NOx emissions at all. Thus, you have reduced cost for ventilation infrastructure underground. You don't need to invest a lot to maintain a cool ambient temperature for the operator to operate. You have reduced maintenance costs, as these are electric engines. And battery-powered loader underground produce a decrease in ambient temperature, which makes it much more convenient for the operator to operate the machine in underground conditions. Why to choose battery-powered loaders over any other equipment? We have developed our own energy exchange energy battery module, which can be quite easily replaced. You don't need any high voltage infrastructure underground in order to recharge the battery. Two sockets of 220 volts are enough to recharge our batteries in only 4 hours. The maintenance, as I told before, is quite reduced, as we are on electric powered equipment, and it provides the cabin operator with unparalleled comfort, as because of the electric engines, there is a decrease in ambient temperature, and there is less heat than in any other machine. We have joined security requirements with to have a better productivity on our battery-powered electric loaders. Our cabins are ROPS and FOPS approved. We have, of course, emergency stop on every machine, audio-visual reversing alarm, and in optional we have aircon and presence detection. We have on this loader a good size and capacity ratio. Inside the cabin, we have designed more ergonomic steering control in order for the operator to be quicker operational on our equipment. So it's easier and more convenient for the operator to steer our machine for small and medium section mines. Sustainability at our mine is a key point of our philosophy. We have chosen carbon-free steel to produce our equipment, and we have a mechanically welded chassis, which make a longer lifetime for the equipment. And as I already told, we remanufacture all our equipment, so the lifetime can be longer. About the capacities and the axles, we have chosen Kessler axle for front and rear. The bucket speed and the lowering time make it quite efficient to use. About hydraulics system and bucket, we have 100-liter dedicated tank for the hydraulic system, integrated filtration, lifting and lipping cylinders, and gear motion pumps on the equipment. About energy now, the voltage of our batteries is 540 volts, and you can charge them up to 80% in only 3.5 hours, with 4 to 6 hours operating time, which is quite decent. And you don't, as I told before, you don't need any high voltage infrastructure underground to recharge our batteries. And we have an optional system of quick replacement of the battery. About the tires, we can provide smooth tires or we have two electric motors on our battery-powered equipment, one for the bucket, of course, and one for the powertrain. We have smooth or studded tires on request from the customer. We can adjust. And now about the conditions of use of our battery-powered equipment. It can be used in quite various conditions regarding altitude up to 4,500 meters high, and the temperature ranges from -10 Celsius degrees up to 35 degrees of heat. So it can be used in quite various conditions. Thank you for your attention, and you're welcome to visit us on our booth number 4 here at MINEX Expo 2023.
You have to stay there. Thanks, Stefan. Any questions from the audience on the AeroMine equipment? A couple of questions. Talking before the presentation, I understand that the cost of batteries have gone down recently. How does the cost of a battery electric unit compare to the diesel equivalent with AeroMine these days?
Between our diesel equipment and our battery-powered counterparts, we have a price gap of something like 20%.
Okay, and does it appear that with the expanding usage of battery-powered underground equipment, is there an expectation that the cost of batteries themselves will go down in the future?
It will depend of the availability of materials to make batteries. As you might know, with the development of EVs, it's concurrential for batteries. But I hope the battery-powered equipment will remain price competitive.
Absolutely, yeah. Just sorry, one more question. Does AeroMine offer sort of a battery rental? Does AeroMine manage the batteries themselves, like a battery as a service sort of rental cost to companies, or the management, the cost of the battery is by the company themselves? They have to buy multiple batteries and manage them themselves?
We can provide multiple batteries directly to the customer. The customer chooses if we buy only one battery or several in order to work continuously.
Okay. Thank you very much, Stefan. So our next presenter, Christoph, he's coming up for the second time, so thank you very much. And we're going to learn about geomechanical passive monitoring systems using hazards. Thanks.
Thank you, Chris. Good afternoon once again. Long time no see. So maybe I will be quick because this is the almost last presentation today. This time I would like to show you some results of our EU-funded project Gemera. And within this project, our activities are focusing on the passive monitoring systems aimed at the identification of geomechanical hazard in underground condition. And this will be few case studies from underground mines all over the world. Maybe a few highlights about the project. The GEMERA project is founded within the Horizon Europe program. Duration is 36 months. As you can see here, project budget is almost 7.5 million euro. And our consortium consists of 20 partners, and leader of this project is University of Oulu. So once again, strong cooperation with Finnish companies. From our perspective, from perspective of mining operator, we are focusing only on the measurement part because, of course, there are many activities within the project, but we are focused on these three parts. First is the passive seismic, which we conduct together with Spanish CSIC company. Second is multi-sensor drone for geophysical measurement, which was developed by a Finnish Radai company. And third one, which I will focus during today's presentation, is the muography, and we cooperate here with the Muon Solution company from Finland as well. But maybe at the beginning, very short explanation about the muons. During the last presentation, I get some highlights about the astrophysics in underground mining, and here you can see some example of it. In general, muons are the most strongly penetrating elementary particles, and their mass are 200 times heavier than, for example, electrons. And this is why they can penetrate the rock mass to the depth of up to 2 kilometers, according to recent measurements. And we recorded the muons at the depth of 1.4 kilometers in Pyhäsalmi mine in Finland, 2 kilometers in Canada, sorry. And scientists from China also measured the muon flux at the depth of 2.4 kilometers below the ground surface. So we know that we can observe these particles deep underground. And what is important, talking about these elementary particles, is the fact that they always go in the straight line in the rock mass until they are dumped. And if we measure the muons in the same place, the muon flux over the year, over the week, over the day is constant, if we don't have density changes over our head. So in case of underground, we can use it, for example, for the deposit prospection or for the evaluation of geomechanical hazard. Of course, I have to say that muography or muon tomography is the thing which is very good known for astrophysics for years already, because they use it for the evaluate the natural background radiation in underground, but it wasn't used until recently in the geomechanical or rock mechanics purposes. And here you can see the muon detector, which is developed by the Muon Solution company. In general, it works in very simple ways. So we have few levers in this detector, and as I said, muons go into straight line from all directions. And because of these few levels, we can determine the direction of the muon flux, and then we can analyze how many muons goes through our detector through the day, month, or a week. And based on this data, we can evaluate the changes in the density over our heads. And of course, this is the totally new thing, but it was already implemented in few geotechnical projects. For example, it was used during the TBM tunneling in France and Switzerland. They monitored the environment around TBM, and it was very effective at the low depths because they managed to identify the local hydraulic network around this tunnel, so it was very effective. It was also used in the underground mine in United States. I will talk about it a little bit later. And because of the theory of the muon flux, it can be also used for the monitoring of cracks and deformation in underground mining and location of any significant changes in density. So if we have any kind of water or gas-filled caverns over us, we can identify it probably with muons or muography. Here you can see the validation of the detectors which were developed by Muon Solution, and here you can see very simple setup. In general, we have two levels, one at the depth of 30 meters, so we have the detector located here. Second at the depth of 10 meters below the ground surface, and here you can see the things in the office which we expected to achieve This is according to simulation, and these are the results of the measurements. Of course, the resolution is not the best in the world, but this is with only one measuring device. So increasing the measuring device and the time, we increase the resolution as well. So because of the good preliminary results, it was implemented in many international projects and also commercial projects. I know that our friends from Neon Solution had some projects in the Buda Castle and in the Hungary. And here you can see, for example, utilization of this method for identification of underground caverns, looking basically on the changes in density in the surrounding area. So at the low depth, we know that these methods work perfectly fine. The question is how we can utilize it in the deep underground mines. And here you can see the average muon flux at the large depth. We conducted measurements. Team Enquist in general is the part of our team, and he measured the muon flux up to 1.4 kilometer. In our case, from the perspective of KGHM, we would like to test it in the Lubin mine. So we focused on the depth of about 600-700 meters below the ground surface. And according to this graph, we can expect the muon flux per year at the area of 1 square meter of about 100,000 muons per year. So quite a lot. We believe that we can see something with it. But maybe some example of utilization of it in real underground mining. This is the measurement of muon flux in United States. The depth is 540 meters below the ground surface. And what is important here, in the first stage of measurement, 2 muon detectors were installed in the chamber F and chamber G next to each other to validate if the results at both stations will be the same. They were the same. The measurements last for 68 days. So then both detectors changed location, one to the bay number 19, second to the chamber number 2, and the measurement lasts for the next 160 days, so quite a lot of time. But here you can see the geological model obtained with the drilling of deposit, and here you can see the results of muography. I need to say that this was the blind test, so mine company doesn't share with the results of geology before the measurement, so the comparison was validated by it. And of course, with these results, we can determine the 2D, 3D density distribution, and of course, we can project in the larger area. This particular site was quite easy to evaluate because this was the lead and zinc deposit, as I remember, surrounded by dolomite. So the changes in density was about 4 times between the polymetallic deposit and the surrounding dolomite. So this, I can say, was quite easy to implement. And another example was the Kemi mine. During the last year, some measurements have been made there, and here you can see probably zinc and copper deposit surrounded by dolomite once again. And here you can see the density changes. The problem with this method is the thing that we measure things over us. So in case of KGHM, we cannot use it to the prospection of deposit because we have the horizontal deposit, so this method cannot be utilized, but we will try to analyze the geomechanical risk with this method. Because progress of exploitation generates some cracks and deformations in the roof. We have quite significant seismic activity in our case, a lot of rock bursts, so we will try to evaluate it. And within the Ajamara project this year, we installed 2 muon detectors in Lubin mine. Of course, it was harsh because, as you may expect, because of the harsh environment, high humidity, these detectors last for about 2 months and died, unfortunately, but we have the second version which works at the moment for 2 months and works perfectly fine. We collect some muons, and this is the general setup. So very briefly, this is the mining panel, G2 mining panel. Exploitation goes from left to the right, and after exploitation we have liquidation by roof deflection, so great deformation here. And we installed two muon detectors, one from this side, and we try to observe the density changes. Of course, after 2 months of measurements, we can say that this will be challenging because changes in density are significantly smaller than in case of polymetallic deposit in United States. And second thing is the fact that it is hard to evaluate our threshold because these densities are constantly changing. But we are trying, probably we will install the next detector to increase the resolution of the measurement and shorten the time of the measurement. And another last thing is the thing that we would like to somehow evaluate it. The geomechanical hazard is the topic which is not fully recognized, but we will try to compare the measurements of muon flux, results of the density changes with the seismic tomography, both active and passive, and also analysis of seismic noise characteristics to determine the crack propagation. And we also will try to compare the results with the stress distribution according to our 3D large-scale numerical model. So we will prepare the set of numerical models which allow us to show how stress changes along the progress of exploitation in the, for example, period of one or 2 weeks. It is very challenging, but this is the beginning of the project. We have high hopes related to this activity, and at the moment, this is all from my side. Thank you for attention.
Thank you, Christoph. Any questions from the audience?
If I can have a question?
Yep, yeah. Please go ahead.
What is the response time for this analysis when you send this source beam and you measure it? What is is it
at the moment
millisecond or second or minutes?
Response of the device?
Yes.
To be honest, I need to check because this device was developed by Muon Solution. I think that it responds directly after the muon occur in the device, but I cannot say correctly. I need to check it.
All yours, Tim.
Yeah, my question was similar. What occupation time do you need? Obviously, these are passive sources, so how long? You spoke of 2 months, but that was more to do with the...
as I said, in United States, at the depth of 540 meters, it was about 210 days to determine this, shape. In our case, it can be more challenging because of the progressing of exploitation. But to be honest, we don't know yet. According to the data presented us by Muon, it should be 5-6 months. But we are starting. We can talk about it after these 5-6 months if it is really working in our case.
Sure. Thank you.
Well, I'm really glad you two asked questions there because I was getting uncomfortable. It's one of those, the more you know, the more you realize you don't know. So I think I've got to read up about this. Okay, thank you very much, Christoph.
Thank you.
And the last presentation today is a topic I'm a lot more comfortable with, and it's Inga Hichosyan.
Almost there.
Like
that was a good try.
But introducing drone technologies, which they have a nice display out in the foyer there. So over to you, Inga.
Thank you so much, Chris. Well, they say they save best for the last. I guess we'll find out very soon. Once again, good afternoon, everyone. Thank you so much for making it till now. I guess it's been a very long 2 days of presentation, so I'll try to be short and sweet so we can all go on with our day and enjoy the dinner. On the side of the introduction, my name is Inga, with a field of analysts, miners, geophysicians, and geologists, just a sales manager. They're overseeing quite a large part of EMA region. That with our product means that I spend way too much time somewhere 3 kilometers below the sea level in South Africa that I'm at home, but that's make the job a little bit of fun. So for the ones of you who doesn't know us, Flyability is a Swiss company of 9 years, and it's the very first company in the world, we like to say, that invented the idea and actually created a drone, a UAV that is designed specifically to be used in the confined spaces and hazardous environments, especially when it comes to the mining industry. So just to give you an idea on the little numbers here, bear in mind that it was a long journey of 9 years. So back in 2014, 2015, we were just two-man company, officially a spin-off of the Polytechnical University in Lausanne. So that was our PhD project for one of our founders. And 9 years down the line, we are quite a growing company, still actively hiring lots of engineers, lots of new sales guys, just as myself. And quite an extensive list of customers that you would see here. That's a little wall of pride for ourselves with regards to the mining industry. Beyond geography, you'd see the names vary from literally a continent to another. And quite a large network of partners all around the globe. So if I have to say one thing about flyability, it's going to be this: no more humans doing dangerous jobs. That's one thing that kept us going from the very beginning. And every decision that we took, every solution that we released was specifically related to this topic. So everything was around safety, everything was around the remote data collection. And I guess out of all the industries out there that we are well presented, mining industry corresponds to it and resonates with it better than anything else. Mining companies are facing a lot of challenges, and as we've seen with the presentations before me, trying to find technologies that will make their operations way more efficient, were also way safer. So you would know better than I do that it's an extremely hostile environment with working conditions that are changing constantly, and any technology, any robotic technology that can make it a little bit more safer, that's definitely on the agenda of all the big mining players out there. So when it comes to the drones, they're just part of the puzzle. And when it comes to our drones, the Elias drones, it's even a more niche of an application. You would see the main applications displayed right here, but the list is literally ongoing. I guess we've been discovering the new ways to apply the technology, to new ways to make those operations way more efficient for our clients, just by talking to them, just by showing the equipment in action. So today we'd focus on the three main applications. But before that, let me give you just a brief idea on what technology is all about. I'm sure most of you have seen it during the forum itself. They were playing a very nice little video of showing LS3 in action. And you've seen us definitely during the lunch break. So the main thing that you see that differs us from all the other UAVs that you know, it's the cage, right? So that's correct. Cage allows us to fly in the spaces where no one else can. Even if you would collide into things, if you would scrap on the walls, the drone will be absolutely fine and safe. Just going to keep going. But that's not the main thing that differs us from all the other UAVs that you would know. Your kids might be flying, or you'll see them taking pictures, very nice pictures outdoors. So all those drones, they rely on the GPS signal, where we don't. We operate in a GPS-denied environment, whether it's an underground mining tunnel, or whether it's any closed asset of concrete or steel that needs some sort of maintenance. And in order to do that, you need to collect the visual data from it. So that's the main difference. So we do not rely on GPS. We operate in a way different manner. And the second main difference that puts us way aside from every other UAV that you know as well is the way we collect the data. So you are able to collect the visual data with the camera and the red payload that you see in front of the drone. That's given. Anyone can do it. But we also mounted a laser scanner on the drone, a LiDAR, that allows you to collect simultaneously, along with your visual data, the digital data. So you can literally digitalize inaccessible environments that we face a lot within the industry. So going back to the applications, I'm going to play a nice little video for you. And I'll focus on the one which I find most relevant, just bearing in mind the core of our business, which was always the visual remote inspection. And what you will see right now is it's a primary crusher on the side of Anglo-American in South Africa. That's an iron ore site, so you'll appreciate the amount of dust, and that's just because of the nature of the mine, of what they're mining there. So the issue these guys face is from time to time the crusher just stops because of the blockages, and that would mean that the whole production stops. And in order to see what is actually wrong, they need to send people into such an environment. There is absolutely no other way to do that. You would have a team of 2 people wearing a nice little helmet, equipped with a flashlight. getting inside there and literally liner by liner checking the state and the condition of the environment to identify where those loose rocks are. Well, by definition, not safe. But aside from this, it's extremely time consuming. So aside from the preparation of the asset for that takes about 45 or 50 good minutes for them to identify where those rocks are. And you will see it at some point in the video. So dusty environment, quite a large asset. I'd say those rocks, they would reach about 1 meter in diameter, easy. You would see it also on the map that is mapping on the right bottom corner. So it's quite a big asset. So the challenge for these guys would be not only the fact that they are walking on the material, which is not safe, that the material is falling on them from the top, which is not safe as well, is actually to see where the issue is. And in some cases, as you would see right now, it's relatively far, so they can't simply reach it. With the drone, you can do it literally standing outside of the asset, so there is absolutely no need to come even closer to the entry point. And as you would see, and it's written right here, it's taken us about 15 minutes, which means less than 2 flights to identify the issue, which we can see on the screen right now. These guys came up with a very interesting number for us, and that was about $2.5 million of savings annually once they estimated the case of doing this type of inspections with the drone or by sending their own employees there. They managed to build a whole business case around that, implement this particular type of inspection almost on a weekly basis. So they save a lot of time and money on this one. So let me move forward just for the sake of the time for another application, which we call ore pass inspection, which is not really, it's more of a mapping those ore passes or checking the conditions of your ore passes or stopes or any mining tunnels underground. Let me just focus a little bit on what you are seeing on the actual screen. So this is the view that the pilot has while he's behind the remote control. So you see everything that's happening beyond the visual line of sight. You will see, you'll see the environment that we are trying to get into, where you can't walk with a handheld scanner, which would be very, very handy. You can't place a stationary scanner either, because you just can't reach those spaces. But you can fly a drone there remotely while you are in a safe distance from the actual assets. So you would see the visual data, as I mentioned earlier, and you also see this little map that's been generated by the LiDAR. So LiDAR is operating based on the SLAM algorithm, which stands for simultaneous localization and mapping, and drone literally does what it says. It localizes itself in space while there is no GPS signal, and it also creates the trajectory so we see exactly where the drone is while we are operating and while we're in flights. So just appreciate the conditions underground, which I'm sure most of you have seen before. Very tough environment, and the type of environment where you can't get any type of reliable data which is not biased, right? This is not a human opinion, there was not a human there. It's something that is digital, something that is recorded. One of the applications in this particular case as well is the quality check after the blasts. That's quite a common thing for this particular guys. That's, by the way, that's a mine in Kazakhstan, a gold mine. And they were very, very interested to find out that there is a lot of ore left after the blasting. So that brings them to a very interesting conversation with their contractors at some point. And last but not least, again, one of the applications and main applications for the drone is the warehouse management. Let's call it like that. So the drone and the software that it's using is able to calculate your stockpile, so calculate the amount of the product that you guys are storing, or your clients are storing in the warehouses or outdoors. Usually it's done in various ways. So now what we see on the screen, those are relatively small stockpiles. Usually they are way larger. And one way to do it is actually measure it with a pool, which is very old-fashioned, but still very much in use in some parts of the world. Or the other way is to actually walk across those stockpiles with a handheld scanner, which is, if not dangerous, just not convenient and time-consuming. What you can do with the drone, you can deploy that, do a little square flight, and in less than a couple of minutes, you will have all the data that is needed. So you're done with your flights, you upload everything into the software, and the software does the math for you. And the good thing of that is that you can check the very same stockpile, the very same warehouse repeatedly and base your decisions on the calculations that are done by those algorithms. Not sure how I am on time. I guess I'm doing well. I'm just going to conclude with this particular slide saying that regardless of the application, regardless of the industry, because we are, as a manufacturers, right, we are operating and presented in various industries, from oil and gas to public safety, with a very specific focus on mining for the last year and so. The value proposition of the product has not changed. The value proposition is exactly what you see on the screen, with a big focus on safety. And the obvious other benefits that comes with it, the reduced downtimes and lots and lots of savings. And by using the solution that we put together, we managed to tick all those boxes. And I am done. Thank you so much for listening.
Thank you very much, Inga. I'm absolutely a big fan of this technology. It's the future of mining. But any questions from the audience to Inga? Mr. Myers?
You can't ask about the price, though.
No, it's not the price. Hi, Peter Myers from SRK. Look, it's fantastic stuff, and when you've got as much grey hair as I've got, you see, you've seen this grow from nothing and just a figment of somebody's imagination to something like this, which is absolutely fantastic. What sort of future developments can we expect? What surprises have you got there that we haven't even thought about yet?
That's a fantastic question. Thank you so much for that. So this is our third product, as I probably mentioned already, and I guess the biggest fear of all the clients that we have around the globe was the obsolescence of the technology. So nobody wants to have something that is not the latest tech. I'm sure all the iPhone users can appreciate this statement. So we tend to say that as a platform, this is a final solution. There is no Helios 4, there is no other drone that's coming next. So everything that is coming next will be related either to the accessories that you can mount on the drone, so various payloads. For now, it's a visual inspection equipment and surveying equipment as well. So we want to tap more into other methods, other solutions. We want to be as the versatile tool as possible at the end of the day. So that's one side of the development. The next side of the development is autonomous flights. Nobody want to fly the drone. Nobody want to be responsible for the technology. Everybody wants to have this peace of mind by just pressing the button, and the drone will do the whole exploration on its own. That is the future for us. That's the big plan. Thank you.
Any other questions from the audience?
I got one, Chris.
Yeah, Tim?
Yeah. Thanks. I'm on an international committee to promote best practice in drone geophysics. But you guys are just a different order of magnitude of complexity and coolness. I'm going to ask you a question you're probably not going to be willing to answer. There's clearly no GPS. How do you do your spatial referencing?
Based on the LiDAR. So LiDAR allows us to localize ourselves in space.
It really is, but you've got to have some control points then. So have you got some base? Maybe I'll chat to you after. You've got to know where you are in order to know where you're trying to get. Yeah.
That's where we're going with the georeferencing option. So that's also the solution that we are capable of doing. So by using the reflective targets, especially when we're operating on the grounds, but yes, the target needs to be known, correct. But in order to just operate, we're using the XYZ coordinates. That's what we do. Hope I managed to cover that. If not, let's chat.
That's great, but extraordinary. Well done.
Thank you so much.
Sorry, one more question, Inga. Does the company offer data processing as part of the service as well? Is that sort of an extra service to receive manageable shapes without making a mess of it?
Great question, Chris. Thank you for that. That's always the big thing. So what is the final added value? Anybody can pilot a drone. That's easy, especially this one. Very easy to pilot, but the whole idea is to capture the data that you need, that you can process. So the answer is no. We don't do any sort of services. We just put them together, sell them to the client, sell them to the end users, come on site, make sure they can operate it, show them how to process the data, and let them be. But again, we provide or we advise on the software solutions that can be used to ease the processing elements. But I'm sure that the type of clients that we're dealing with, especially in mining, they are very well aware of what they need in terms of data, so they know how to process it. At the end of the day, the data that you get is an LAS, LAZ files that you can process in absolutely any software. And if you already have one on site, you can just keep going with the solution that you've got. But no, nothing on the house. Thank you.
Super. Thank you very much, Inga.
Thank you so much.